Welcome back to Maths with Mrs. J. I'm going to start a series of videos about linear functions. Now, linear functions are functions that graph as straight lines. In order to understand how we graph our straight lines, it's important to have some understanding of what we call gradient. Now, the gradient of a line is a measure of the slope or steepness. You might even notice that if you're driving around, say, the Sunshine Coast hinterland or somewhere where there are some quite steep roads, they might even have a warning sign up saying caution, steep gradient, 1 in 10 or something like that. We measure the gradient by rise over run. So how much something has gone up divided by how far it's gone across. A straight line is going to have a constant gradient throughout that line. Curved lines will have a changing gradient, and that's where we bring in our differentiation and our whole calculus idea. If you have a line that's going up from left to right across the page, the gradient will be positive because you'll have a positive rise divided by a positive run. If you have a line that's going down from left to right, then you will have a negative rise divided by your positive run, so you'll have a negative gradient. We have two special cases here, and our special cases are our horizontal lines and our vertical lines. With a horizontal line, you have no rise. So when you do rise divided by run, you're getting 0 divided by something, say 2 or something, and that's always going to be 0. 0 divided by any non-zero number is going to be 0. In the case of a vertical line, your run is 0. And if you're trying to divide something by 0, well, we can't do that. It's undefined in maths. So they are your two special cases. A horizontal line will have 0 gradient and a vertical line will have an undefined gradient. Now, to work out that rise over run, I've shown you this y2 minus y1 over x2 minus x1. They're subscripts. That means the y value of the second point minus the y value of the first point. The x value of the second point minus the x value of the first point. What you call the first and second points is really up to you, but you just need to be consistent that you're not going to call this x1, y2, for example. So if you're going to call this negative 2x1, then that has to be your y1, and that has to be your x2 and your y2. So using our rule, so our gradient from A to B is going to be, well, y of b minus y of a if you like, but we can do y2 minus y1 over x2 minus x1, which is going to be 10 minus 5 over 3 minus negative 2. So we get 5 on 5, which is just 1. If we were to draw a diagram of that, we could see our right-angled triangle and we could see our rise was 5 and our run was also 5, which makes sense that we get a gradient of 1. Doing the same sort of thing here, gradient from A to B, second y value minus first y value over second x value minus first x value. So 4 minus 7 over 5 minus 3. So we're going to get negative 3 on 2, and I would just leave it like that as an improper fraction. That's perfectly fine.